Okay, so find all three complex roots of the function. So what you can do is, because this is kind of a shot in the dark, you can write down the P's and Q's. P is 1, 3, 5, 15. Q is 1, 2, and 4. So this gives us a lot of options for P over Q. So just to kind of get this started, notice that there are all positive coefficients. Did you guys notice that? So that means I am definitely not interested at all in plugging in positive numbers. They're not going to work. So that rules out half of my P over Q options right there. There are no positive roots. So that's a huge head start on the problem. The other thing I'm aware of on this problem is if I plug in -1, if you find f of -1, it's going to come out to be -4, right, plus 11, minus 26, plus 15. In other words, it's going to come out to be negative. But if I go to -2, I get -24 plus 44 minus 52 plus 15. Is it still negative? Actually, hold on. Is it still negative? Yeah, I think it is. Let's try f of -3 real quick. So it's -27 times 4. 108, -108, plus 99, minus 26 times 3 is 78, plus 15, this is still negative. I'm trying to find out how far I should go into the negative realm. See? All right, and let's try f of -4 real quick. Oh, yes, f of 0 is positive. Ah, yes, I missed that. F of 0 is positive. That's my clue. Thank you. I forgot to check f of 0. F of 0 is simply 15. Okay, so what does this mean? If f of -1 is negative, but f of 0 is positive, if the graph really does contain the point -1, -4, and the point 0, 15, I know there's x-intercept somewhere between -1 and 0. See? So the graph just crossed from here to up here. Okay, so I'm going to be looking for negatives only and between -1 and 0. That greatly reduces my work. Okay, so let's see. I need a negative number that's between 0 and -1. I can try -1/2, -1/4, -3/4. I can try, that's pretty much it. -1/2, -1/4, and -3/4. These are the only options I have that live between -1 and 0. Okay, so it turns out that -3/4, I believe, works. I'll show the work for it. So some of you guys got this right away. I'm not sure how, but you just maybe got really lucky on it. But -3/4 was the magic number. And the rest is easy. Now that you have that, you could just think of it as 4x squared plus 8x plus 20, and you can do the quadratic formula from there. X equals -8 plus or minus square root of 64 minus 4 times 80 all over 8. So you end up with -8 plus or minus square root of -256 all over 8, which gives you -8 plus or minus 16i all over 8. So the final answer is, remember to factor out the 8 on top. It's basically -1 plus or minus 2i. So my answers were -3/4 and -1 plus or minus 2i. The ugly part, the conjugate thing, that just came from the quadratic formula. So it wasn't that hard to get. Alrighty, we have about 5 more minutes. Maybe we can blaze through some of these easier ones. Yeah, so Mr. Short wasn't trying, I should have been trying f of 0 there. Does anyone understand how we kind of trim down that long list of options? I was trying to figure out, like, what values of x, what two consecutive numbers gave me a sign change, and it was -1 and 0. So that's how I knew to try -1/2, -1/4, -3/4. All right, that's really annoying little eraser there. Let's go to the next one. So you guys did really well on this stuff, for the most part. There's so many ways to do this, but you could just set this equal to x, and just think of it as 2 to the x power is 4√2. And then just try to think of the 4 as 2 squared, and think of the rad 2 as 2 to the half. So just think of it like this. This is 2 squared times 2 to the half. Adding 2 plus a half is 5 halves. So basically, 2 to the x is 2 to the 5 halves. And that means x is, of course, 5 halves. This is the same kind of thing. Move this over, and you get the 4th root of 3 is equal to the rad 3 to what power? You gotta be careful with this one. But if you write the left side as 3 to the 1/4, and you write that rad 3 as 3 to the half, this question is not that complicated. 1/4 is half of x. So multiplying by 2, we get 2/4, so x is a half. So just put half here. This one, you might want to rewrite that 1/e cubed as e to the -3. And ln of e to the -3 is -3. Or if you want to, you can bring this -3 out front, and you get -1 ln e. Ln e means what power of e is e? So that's, of course, 1. So the answer is -1. There's an imaginary, not imaginary, but there's an implied 10 whenever you see a log and there's no base. So this is asking, what is log base 10 of 100 to the rad 2? You can bring the rad 2 to the front if you like, if it's annoying you. And this just means what power of 10 is 100. So that's 2. So the answer is 2√2. And I'll finish the recording during 6th period and post this online as well. Okay, let's go on to the next problem here. So clear out the ink. All right. A little harder to erase with the Microsoft Eraser. Okay, so now we're on part D. Thank you for your patience. Oh, we already did part D. Sorry, okay, part E. The log is a base D log, and we have D to the 1/5 basically there. So we have basically log base D of D to the 1/5. The answer to this problem is 1/5. The reason is a log base D and a D to the anything are just inverse functions. So these sort of cross out to make 1/5. Or another way of thinking of it is you can bring the 1/5 in front, leaving you with log base D of D, which means what power of D is D, which is clearly 1. The first power of D is D. Anyway, the answer is 1/5. Let's go on to the next problem. Okay. And this one is t to the log base t, 4 log base t of 3. So this 4 can be moved to up here. So this reads t to the log base t of 3 to the 4th. In other words, t to the log base t sorry about that. log base t of 81. That's what we're dealing with. Okay, and then this is 81. And again, the reason is t to the power anything and log base t of anything are inverse operations. So to the trained eye, this looks just like, this reminds a mathematician of something like, what's 81 cubed and then cube rooted? Or what is half of 81 and then times it by 2? So these basically undo each other. If you're having trouble understanding that, understand that this question, log base t of 81, is asking what power of t makes 81. And then this is asking t to what power of t makes 81. The answer is 81. So basically it's saying what is the power of t that makes 81, and then take that number and put it on t, that's going to give you 81. So a little hard to grasp, but true nonetheless. Those are inverse functions. Okay, this next one, you can rewrite this as 12 to the minus 2. So log base 12 of 12 to the minus 2, also known as 144. Oh, sorry, 1 over 144. And you can move the negative 2 in front, and log base 12 of 12 is 1. Okay, so the answer to this one's 81. The answer to this one was 1/5. The answer to this one is negative 2. And let's go on to the next page. Okay, so those are just sort of exercises where you're not really doing anything but exercising your understanding of the properties of that mathematics. All right, let's go on to number 3. Now you're solving, so you're using those skills in a broader context. So you have 7, basically you have 7 squared, pen's not working. 7 squared, 5 minus 4x, equals 7 to the 2x, and so you can basically just cross out the 7's. So you end up with 10 minus 8x equals 2x. 10 equals 10x, so x is 1. So I'll write my answers on the left. The next one, you're going to have to go ahead and solve this a little more carefully because you have different bases, but you can start by doing an ln or an log on both sides. So something like this. Bring this out front. Bring this out front. So we have x minus 4 ln 2 equals 1 minus x ln 3. And we need to distribute this out. The reason is some terms on the left have x, others don't. And the same thing happens on the right. So we need to kind of get it all expanded. Otherwise we won't be able to get the x's on one side. Okay, so we have x ln 2 minus 4 ln 2 equals ln 3 minus x ln 3. And let's bring all the x terms to one side. So we have x ln 2 plus x ln 3 on this side. And let's bring all the non-x terms to the other side. So we have ln 3 plus 4 ln 2. And then we can factor out an x. And divide. So some of you left your answer like this, ln 3 plus 4 ln 2 all over ln 2 plus ln 3. But the instructions actually said to write it as a single ratio. So like 1 log on top, 1 log on the bottom. So we're going to write this as ln 3 plus ln 16 for the top, and the bottom as ln 6. I just multiplied the 2 and the 3. So where did I get 16? I moved this 4 up here. So it's ln 3 plus 4 ln 2, but it's also known as ln 3 plus ln of 2 to the 4th. So this is a little bit hard to see. Let me kind of rewrite this part. I'll write it a little smaller. So I have ln 3 plus ln 16 is what I found, which is really ln 48. So the answer I was looking for in this problem was ln 48 over ln 6. But there's an infinite number of ways to re-express that. So actually that's this answer. ln 48 over ln 6. Alrighty. The next one, you can see they both have a log-based force, so the logs are 1-to-1 functions. So you can just cross those out, and if you solve this, you get x equals negative 31. On the next one, you can't cross them out yet, but you can square the base and the argument at the same time. We talked about that. So this now reads log base 9 of x squared plus 6x plus 9 equals log base 9 of 13, and then you can cross out the log 9's. So you end up with this quadratic, x squared plus 6x minus 4 equals 0. I already brought the 13 over. And you can solve this using the quadratic formula. X equals negative 6 plus or minus the square root of 36 plus 16 all over 2, which is negative 6 plus or minus root 52 over 2. 52 is 13 times 4. So we have negative 6 plus or minus 2 rad 13 all over 2. And reducing, we get negative 3 plus or minus root 13. Now you have to kind of check to see that this makes sense. If you go back to the original question, we can see that only one of these will work. You actually are not allowed to put negative 3 plus root 13 here because it's a positive number. So the correct answer that actually works on this problem is x equals negative 3 minus root 13. And the reason that is the only answer is because that's a negative number. And when you put it in right here, you get log of something positive equals log of something positive. If you try to use the negative 3 plus root 13, that's a positive number. And when you stick it in, you get a domain issue. So you can't have that. So a lot of these problems, you have to kind of check your answers in the end, and only one of them will work. Okay, let's go down to this next one. Maybe I can erase the page real quick. I don't see any quick way to do that. Oh, maybe I can use selection like that. Wow. All right. Anyway, I'll just have to use the eraser. So let's clean this up. I'd rather use Smart Ink anyway. That doesn't work. Okay, let's try Clear Ink. That didn't work. Let's try Microsoft Ink, eraser, and it takes forever, but we'll do it. Not working. Fair enough. I will delete it. Pause recording and delete it. Sorry about the weird. Alright, that took an extremely long time to erase, but it's done. So let's go ahead and finish this up. So next is this problem down here, part E, I believe. And the bases are the same. There's no base on the right, but that's okay. So what I'm going to do is combine these into one log. So I have log base 2, and it's x times x minus 2 equals 4. And this gives me log base 2 of x squared minus 2x is equal to 4. And then I'll move the 2 over and bump the 4 up. So I end up with x squared minus 2x equals 2 to the 4th, or x squared minus 2x equals 16. So this is just a completing the square problem, or you can use quadratic formula if you bring everything to one side. And you could just do x equals 2 plus or minus the square root. 4 minus 4ac is 64, negative 64. So you just end up with 2 plus or minus, and that's 68, which is 4 times 17, so 2 root 17 all over 2. So you end up with 1 plus or minus rad 17. Again, we have to check which answer makes more sense. So if you look back at these x's, it makes sense to put in a 1 plus root 17 for x, but it does not make sense to plug in a 1 minus root 17 because it would cause a negative domain, or a negative value going into a log. So you can't have that. But you can use 1 plus rad 17, and that is our answer. Okay, next is this one here. You can do this problem pretty much straight up, but you need to move this 2 up to here. And that way it'll look like log base 4x squared plus log base 4 9 equals 3. And then you can collapse that into log base 4 9x squared equals 3. The 4 comes over and bumps the 3 up, giving you 9x squared equals 64, because it's 4 to the 3rd. And dividing, you get x squared equals 64 ninths. Square rooting, you technically get plus or minus 8 thirds, but this problem prohibits negative inputs. Look at the x right there. So we're going to go with 8 thirds only, like that. Okay, the next one, it suggests that you multiply by e to the x. That's for both sides, of course. So you end up with e to the 2x minus 20 equals e to the x. You might say, well, what happened to the middle term? It just became a 20. What happened there? Well, e to the x times 20 e to the x, negative x, is literally 20 e to the x times e to the negative x, or you could say e to the 0. And since e to the 0 is 1, I just got 20 as a middle term. I'm erasing that for space reasons, but if you need to rewind the video, you can. Okay, so anyway, we ended up with this really weird looking problem. And what I'm going to do is I'm just going to pretend that it's a quadratic. So it looks sort of quadratic, especially if you bring everything to one side. So e to the 2x minus e to the x minus 20. And the coefficients on this problem are 1, I'll put them in red, 1, negative 1, and negative 20, like that. So you could just basically do a quadratic formula for this. Alright, so you would just basically do not x equals, but e to the x equals negative b, so that's going to be 1, plus or minus square root of b squared minus 4ac, that's going to be plus 80, all over 2a. So this is awkward at first, but it's actually working out pretty well. We've got 1 plus square root of 81, which is 10, over 2, which is 5, and 1 minus square root of 81, which is negative 8 over 2. So we're getting two answers for e to the x, okay? So we talked about e to the x earlier in the year, and we said that e to the x can equal 5, but e to the x cannot equal negative 4. And the reason is e to the x, although very hungry and you can plug anything into it, it never gives us a negative or even a 0 output. Okay? So basically, e to the x is always shouting, I am hungry, which means you can plug anything you want into it, and I am positive. I am hungry and I am positive. So this is actually impossible right here. That doesn't make sense. But e to the x equals 5 can be solved. That would just mean x is ln 5. So again, only one answer to this problem, like many of them. Let's go to the next problem. Pause my video and do some erasing. Okay, and then the next problem in this set is two different bases again. So we're going to have to do that little trick where you square the base and the argument. So let's do that in green. So we'll square there and there. So you end up with log base 4, x squared minus 2x plus 1, minus log base 4 of 2x is equal to 1. And collapsing these into one log, it's a subtraction, so you end up with a fraction. So it's x squared minus 2x plus 1 over 2x, like that. And this is equal to 1. So the 4 moves over like this, and the 1 bumps up, so we get 4 to the first. So this is actually what the problem looks like. It's x squared minus 2x plus 1 equals, over 2x, excuse me, equals 4. So multiplying this over, we get x squared minus 2x plus 1 equals 8x. In other words, x squared minus 10x plus 1 equals 0. And now you're ready to do CTS, completing the square. So you do x equals 10 plus or minus the square root, 100 minus 4, all over 2. That's 10 plus or minus, now it's root 96. 96 is 16 times 6, so you can pull out a 4. And this just reduces to 5 plus 2 root 6. Or minus, but I just want to remind you that oftentimes one answer is not going to make sense. So do I want to go with the black plus sign, which gives me a positive input, or do I want to go with the red minus sign, which gives me a negative input? 5 minus 2 root 6 is slightly, actually, hold on. 5 minus 2 root 6. Is 5 minus 2 root 6 negative? 5 minus 2 root 6 is, I'm grabbing my calculator. I should be able to do that in my head. 5 minus 2 root 6 is technically positive, but the problem is when you plug it in, we have issues. So if you go with 5 minus 2 root 6, that number is 0.101, which you're not allowed to plug in here, because this is going to be negative 0.899 or whatever. See the problem? So you can't use that minus solution because it produces an issue with the original problem. Okay, so we're going to go with just the one answer. Just put only here. All right, let's go to the next page. The next question asks us to match this equation to the graph below. This problem is actually pretty simple. If you know that this means decay of 1/4, then it has to be basically answer choice D. The other way you can look at this is you can rewrite this as 4 to the minus 1, which means this is really 4 to the minus x. Negative x means you're going to reflect it over the y-axis. So reflect over y-axis. That's what negative x always means. So imagine taking a 4 to the x graph and reflecting it over the y-axis. That's another way of thinking about it. That would give you this red curve, see? So D it is. All right, next. Okay, so the next problem is this one. This is a little bit tough, but I kind of gave you a clue here. See the y equals 3? That means that C is 3. So you already know right off the bat that y is equal to a times b to the x plus 3y, because normally an exponential would have this horizontal asymptote, this blue horizontal asymptote, right on the x-axis. Normally that's right on the x-axis. But it's been upshifted 3, and adding 3 at the end means upshift 3. So we're good. I'm pretty sure C is 3. See? That's a huge starting clue. And now you can just use the coordinates of the points I gave you and plug them in. So I said x is 1, y is 2. See? That's what I meant when I said the graph passes through 1, 2. So let's plug those in. I got 2 equals a times b to the first plus 3. From this I learned that ab is negative 1. Hang on to that. Let's use the other point I gave you. That's this one. So we're using this. These 2 points are on the graph there. I said 2 zeros on the graph, so that means x is 2, y is 0. And you can just put that in too. So same model. It's 0 equals a times b to the second plus 3. In other words, ab squared is negative 3. So armed with both of these, you should be able to figure out that b is 3. Let me show you how. I'll come over here on the left and do my work in red. If you take ab squared equals negative 3 and divide it by ab equals negative 1, you're going to get b equals 3. And then since ab is negative 1, you can find that a times 3 is negative 1. So you basically just end up with a equals negative 1/3. And now you've got everything. So here's my answer in bright green right here. Y equals a times b to the x plus c. Lots of 3's there. And there are other ways of writing this. In fact, this graph can also be visualized as an upside down exponential shifted up 3 and also shifted to the right a space. But let's save the multiple understandings for another time. We have a final exam tomorrow, right? All right, let's clean this up and pause the video. Okay, the next question says find the domain and range. Now, this is just an exponential function, so you could actually even draw it if you wanted. 2 to the x, looks like this. The negative means it's upside down, so that'd be like this. The plus 4 means you're shifting up, so basically it looks like this. Shifted up 4, so that there's a horizontal asymptote at y equals 4. We have an upside down exponential graph. Okay, so this is actually our graph, and it's kind of nice to have the graph because then you can just answer domain and range visually, but clearly the domain is all real numbers, right? And the range is basically y's that are less than 4, because this is the y equals 4 line. So you would just basically say negative infinity to 4. Okay? That's one way of doing it. The other way to do it is just to know the domain and range of an exponential, and then add 4 to it, and also multiply the range by negative 1. But let's just go on to the next one. This one is a little more, it's a little less likely you'll be able to graph it. I don't think you'll be able to graph it. But you need to understand that x plus 3 here is a base. So if it's a base, it has to be positive, and it cannot be 1. So I'm going to write both of those facts. Also, this argument has to be positive. This is called the argument, and it has to be positive. So armed with both of those, we can solve for the domain. Okay, so after writing down these facts and not just thinking them through, I have things I can work on. So I can take these statements like x plus 3 is greater than 0, and I can write x is greater than negative 3, see? And I can take this statement, x plus 3 is not 1, and I can interpret that. That means x is definitely not negative 2, see? And this statement here, 5 minus x is greater than 0. Okay, well then x is less than 5 if you add the x over. Okay, so you just end up with x is less than 5. So altogether we have these statements, and we can just kind of understand this as one solid answer. So I'm thinking of numbers that are greater than negative 3 and yet less than 5 and not negative 2. So this might be kind of what you're dealing with. Let me go ahead and redraw that number line. So greater than negative 3 but less than 5 but not negative 2. So it looks like our domain is all the numbers between negative 3 and 2 and all the numbers between negative 2 and 5. And it's all exclusive, because logs are so finicky you can't ever have 0 in either the base or the argument. Okay, so that one's not a guess and check. It's not a thing you do in your head. You write things down, you solve it. Okay, now let's talk about the range. Now the fact that this is a log function means it has an all real numbers range in the same way that the exponential in number 6 had an all real numbers domain. So we would expect for the range, so that last one was a domain of course, if we're talking about range, it's normally all real numbers, and I don't think adding 4, that's the upshift, I don't think adding 4 is going to change that. It's just going to be basically all real numbers still. Okay, so the range can't change if it's all real numbers just by adding really any transformation to my range that's in the dirt family. That cannot affect my range. All right. Okay, on to this next problem. So remember that some problems can only really be done with a calculator, or in the old days they would use what's called a log table. So this particular problem can be solved really on any calculator by doing ln 1456 over ln 14, which you would then type. So you just do ln 1456, close parentheses, over ln 14, close parentheses, and that gives you about 2.760 if you're running to the nearest thousandth. You can also use the LOG button, and the interesting thing is it doesn't matter. You'd still get 2.760 as long as you use the same button top and bottom. Okay, for this next one, you're going to want to go into your calculator graphing editor and type in y1 equals ln of x cubed plus 6x squared minus 3x all over ln 3. That's my way of typing log base 3 of x cubed plus 6x squared minus 3x. And y2 equals just simply 4 minus 2x. Okay, now when you press graph, you should see the following image. Okay, so this is after entering both functions into the editor. See? Oops, I forgot to do the over ln 3 here. So let that be a lesson to all of us. I entered both functions and you can see interesting domain issues there. Here comes that line. This is the line 4 minus 2x, the red function, right here. But you can see they do intersect, right? And they probably only intersect one time. So you're going to be checking to see if you could find that point right there. Okay? And to do that, of course, you would need to use the intersect feature. Okay, so the intersect feature is a little hard to use sometimes, especially on this problem. So if you go to calc, you're going to be choosing the intersect feature. And you got to be real careful. Right now, if you look very closely, it says y1 at the top, and it's asking you which curve you want to cross with which curve. So it's asking what the first curve is, and it displays y1 at the top. That is correct. We do want the calculator to think of the first curve as y1. That's this goofball-looking curve like this. Okay, the problem is there's like an asymptote going on, or something funky at least. Yeah, asymptote I think going on there at 0. So notice that the cursor is at 0, comma, y equals, I don't know. See how it's blank here? That means that the calculator is kind of frozen right now because it's right on the asymptote. So what you need to do is just press the right arrow. You got to get off that asymptote and go somewhere else on the curve. Okay, so just put your cursor somewhere else on the curve, and now you can press enter, and the calculator understands that y1 is the first curve you want to discuss. And it automatically defaults to y2 as the second curve, as it just did. So the red circle I just put up there says y2 equals 4 minus 2x. Okay, so the calculator wants to know if this is the second curve we're interested in, and I'm going to click enter, yes. It's asking me to guess, so I'm going to go and put my cursor as close as I can to the intersection point and press enter a third time, and I get 1.166. Now the y value looks to be very, very similar to the x value. That's a coincidence, and I don't care about the y value. I was asked to find what x was. Look at the original problem. What is x? See? Okay, so basically you want just the x coordinate of intersection, and it is about 1.166. Round it to the nearest thousandth. Okay, the next problem is a money problem, obviously. Okay, so it's important that you find the word compounding somewhere in the sentence. So it says right here, compounded monthly, so it's really important that you use the right formula. A is equal to P times 1 plus R. R is 0.025. Over n 12, because this is monthly, to the 12t. Okay? So this is sort of the way the bank operates. It uses a 2.5% interest rate, compounded monthly. The A, the P, and the T, those all depend on the customer. But the R and the N are bank features. Okay, each bank does their own thing with R and N. So I kind of got my little model set up, and now it's time to actually use it. So in this problem, it says that she finds she has $900. Now this is after waiting 6 years. So it's actually 600 on the, or excuse me, 900 on the left, and I don't know what P is. I just know that I waited 6 years. So T is 6, A is 900, what is P? So you can actually just, basically you just do this, type 900 times 1 plus 0.025 over 12 to the negative 72. So why would that work? Because this right side is P times 1 plus 0.025 over 12 to the 72, and we're trying to bring it over to the other side, so we're just dividing by that thing to the 72. In other words, use a negative exponent on this side. Okay, well anyway, you can simply type that in, and we have 900 times 1 plus 0.025 over 12 raised to the negative 72, and it says $774.76. So my answer is $774.76 must be what was deposited 6 years ago. Okay? How long does it take to triple your money? Well, you can start with P equals $1 if you like. $1, it doesn't matter that, or sorry, A equals $1. P, what am I saying? P is $1, that's the starting amount, my bad. Let's try that again, Mr. Short can't talk today. Let P be $1, let A be $3, see? Or use 10 and 30, or 100 and 300, or simply use P and 3P. But we're going to set up a continuously compounded formula. Notice the new adverb there. So we're going to be using continuous compounding formula, A equals PERT, where A and P are just in a ratio of 3 to 1. So you can use whatever you want. You can use 3 and 1. You can use, like I said, 30 and 10, or just P and 3P. That would work too. But in any case, the P cancels out. So we end up with 3 equals e to the RT. 3 equals e to the RT. Okay? Now the interest rate is 7%, so it's 3 equals e to the 0.07t. Don't forget that hundredths on that decimal there, okay? It's 7% is 0.07. Now to solve it, you're going to basically do ln 3 equals 0.07t, divide by 0.07. So t is ln 3 over 0.07. Okay, now you can type this in if you want, but I'd like to look at it first before we do. What we're saying is to triple your money, the time will be ln 3 over the rate. If you want to quadruple your money, that's 4 times the money, it would be ln 4 over the rate. If you want to double your money, it would be ln 2 over the rate, and so on. So this is kind of a little trick. T will be ln of A over P all over K, or R I should say. We're doing money problems. K is usually used for like temperature and stuff. But see that little formula? That will help you get the time required for anything to happen. Double your money, triple your money, quadruple your money, whatever. Okay, well in any case we need the calculator, so we're going to do ln 3 all over 0.07. That is 15.694. So 15.694 in the context here begs years, because we're talking about years of waiting with your money in the bank. Okay, here's another one. Assume the bacteria doubles every hour. Find K. All right, so we just said that T is going to be ln A over P over R. If you're applying that to this problem, instead of A equals PERT, it's N equals N naught e to the KT, but you could sort of just rearrange all the variables, and T would just be N over N naught ln of N over N naught over K. It's just by analogy. Like I'm not all I'm doing is just sort of modifying this money case for the science case. Final amount over initial amount, log it, divide by the rate. So things have a different letter name, but they're all basically meaning the same thing as the money case. Right? Alrighty. So it turns out that's the answer, where N naught is basically twice what, or half of what N was. So basically N over N naught is 2, because you're doubling. So this is just 2. The answer is ln 2 over K, basically. So T equals ln 2 over K. Now they wanted us to find K, so you could just kind of switch these, and it would be K equals ln 2 over T. And they said it was every hour, meaning every 1 hour, so you could just go ln 2 over 1. So this is our K value, it's ln 2. If that's too confusing for you, then that's fine. Let me just show you a completely different way of sort of approaching it. Just start with the law they gave you, okay, and just write 2n naught on the left, because you're doubling the amount. And put 1 here, because it says every 1 hour. Divide both sides by n naught. Log both sides. And you've got the same answer. It just doesn't, maybe, you may not totally understand what I was saying a minute ago, and it's nice to understand these ideas so you can jump faster to answers, but if you have to go through a method like that, that's fine too. Okay, the next example is talking about an iPhone, and it said that the iPhone has a capacitive touchscreen. A capacitor is a commonly used electronic component. I showed some pictures of capacitors. You've probably seen them before. When a voltage is applied to the 2 wire leads of the capacitors, it will charge up to the model, according to the model. The velocity in the capacitor is the velocity applied times 1 minus e to the negative t over RC, where t is the time in seconds, R is resistance in the circuit, C is the capacitance. Capacitance is something that each capacitor has written right on it. So you will see the capacitance written right on the capacitor. Assume that the resistance is 15 ohms and C is 0.01, let's say farads. If 3 volts are applied, find the time it takes for the capacitor to reach 2.2 volts. So basically what we're saying is 3 volts are applied, so we can use that. 2.2 volts is the voltage in the capacitor, and everything else is just plug it in. Find the time, it says, and RC is 15 times 0.01, also known as 0.15. So we basically have 2.2 equals 3, 1 minus e to the negative t over 0.15, and now you begin isolating t. First you divide by 3. Then you subtract 1. So we have 2.2 over 3, but we're taking away 1. So now we have basically, I'll switch to a different color, negative 0.2666 equals negative e to the negative t over 0.15. Then you'll just cross out these negatives. Then you'll ln both sides. So we're going to ln that thing. And we get a negative answer, actually. So we get negative 1.3218. It's actually 755, blah, blah, blah. I'm just going to leave it on the screen. Equals negative t over 0.15. Then you cancel the negatives again, like that. And lastly, multiply over 5.15. So this looks like a t here, but this is a positive sign. I'll just erase it. Okay, so basically the negatives canceled out. Multiplying by 0.15 gives me 0.198 rounded to the nearest thousandth. So t is about 0.198, and this is measured in seconds. So in under 1/5 of a second, the capacitor is charged to about 2/3 of the voltage you applied. So if you stick a 3-volt battery on this capacitor, okay, it's a 3-volt battery, this thing's going to start charging from 0 volts on upwards towards 3 volts as it begins to charge up. It will reach 2.2 volts in about 1/5 of a second. See, if you really want to wait for it to reach 3 volts, it's going to take a long time, and may not even be completely possible by the models from this model. Like, it'll just charge towards 3 volts. Okay, next is our bonus page. Alright, so I gave you a table of data. Mr. Store's soup temperatures last night are in the table below, assuming the room temperature is 72 degrees Fahrenheit. Find the missing temperature to the nearest thousandth of a degree Fahrenheit. Use Newton's law of cooling. Okay, so Newton's law of cooling is given right here, and you'll use it again next year. So here it is. And what we're going to try to do is basically find, well, we're going to try and answer the question, what is the temperature after 5 minutes? That's the question. So we know the temperature at the 0th minute. We know the temperature at the 10th minute. And what is it halfway between? So what you cannot assume is, oh, it dropped 60 degrees in the first 10 minutes, therefore it dropped 30 degrees in the first 5 minutes. No, that's called using a direct proportion when you're not supposed to. Okay, these are exponential growths, not linear growths. Okay, so what you want to do on this is start with the law. U of T, I told you you have to know what that means. This is the current temperature. T is the surroundings temperature. And U naught is the starting temperature. Okay? It's that simple. Notice T shows up twice. All right, there's a reason for that I'll teach you next year. Okay, the other stuff is just stuff we'll have to work on. So let's go ahead and start. We know that the current temperature of the soup is 130, so we're going to use the first and last data points because the middle one's a mystery. So the current temperature is 130. Now this is in an environment that is 72 degrees plus, and then with an initial temperature of 190 in a temperature surroundings, a temperature of 72 degrees, e to the k t, where t has been 10 minutes. Okay, so we're actually good to go. We're going to subtract the 72, right? And this is going to give us 58. 190 minus 72 is, of course, 118. We're going to divide by that 118, so 58 over 118. And that's, you know, it's 0.491, blah, blah, blah. To get rid of the e, we'll ln. So ln that day. And we get that 10k is approximately negative 0.7102, blah, blah, blah. Dividing by 10, we learn that k is negative 0.07102, blah, 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 which I'm going to store in my calculator as alpha k. All right, so don't forget to divide by 10, and then store it as alpha k. You can hear me clicking away right here on my calculator. Okay, now you're going to use it to study what happened in the first 5 minutes. So let's just restart this problem. Now that we have k, I'll save that here. And kind of running out of space here, so let me give myself a little more room. Sorry for those who felt like they didn't have enough room on this problem. Give myself a little more room. I'm going to cut off my work there. All right. This was 0.491. Okay. Okie doke. So now let's go ahead and restart this. This time we're going to use maybe like the first and second data points. So we'll use these two data points. So we'll just go like this. The current temperature is I don't know. So we'll call it U of t. I don't know the current temperature. In a temperature, a surrounding temperature of 72 degrees at a starting temperature of 190. And this is after a 5-minute wait. And k I know. K is stored in my calculator. So I'm just going to basically go like this, 70. I'm just going to actually type this. So I'm going to type 72 plus, and that's 118, and then e to the, and I'll literally type 5k because my calculator remembers what k is. And it gives me the answer. And it's very, very accurate. 154.728 degrees Fahrenheit. 154.728 degrees Fahrenheit. So notice how close this actually is to the estimate that if it dropped 60 degrees in 10 minutes, it would drop 30 degrees in 5 minutes. But if you had gone with that logic, you would have answered 160. And that's not the right answer, it's 154.728. Alrighty. Let's go on to our next problem. Alright. So this one is what we call a logistic growth formula. And we're just trying to basically just find P of 15. So I don't want to get too into logistic growth this year. We'll do that next year if you're in the BC class. If you're not planning on taking Calc BC, you probably won't see this topic again at all. I don't think you even see it in high school from here on out. Maybe in your science classes. Okay, well anyway, P of 20 is 43.5, so that means you actually know that the left side is 43.5, and you know that the T is 20, so you're going like this. 43.5 equals 50 over 1 plus 4 e to the 20k. And I'm in a position to find k, actually, so what I'm going to do is trade these straight up. So I just make a switch like this, putting the 1 plus 4 e to the 20k here, and putting the 50 over 43.5 on the right. 50 over 43.5 is on my calculator right now. I'm going to subtract 1 and divide by 4. So I just got basically e to the 20k is approximately 0.03735 yada yada, which I will then ln and divide by 20. Okay, so this gives me k is approximately negative 0.16436, etc., which I'm going to store as alpha k. When I store it as alpha k, it'll erase what I had in my calculator for k and update it to the new value of k for this problem. If you have to go back to number 1 to make corrections, make sure you update the k value. Kind of start over on that. Okay, now I'd like to find p of 20. P of 20 means what is the population when the little t is 20. And now, see, I know k. So I've got 1 plus 4 e to the k times 20, which I plan on just typing. So I'm just going to go 50 over, make sure you've got parentheses around this thing. That's really important. 1 plus 4 e to the, and 20k is your power. So make sure you got the powers where the powers are, the denominator separated in parentheses like I showed in green. But this comes out to haha, I just caught my mistake. Sorry, I was hoping to find p of 15. Sorry, I was trying to find p of 15 and I actually found p of 20. I was wondering why my calculator said 43.5. It took me right back to square one. Okay, so I wanted p of 15. So let me update this. Sorry about that. This should be a 15. This should be a 15. There we go. So I just need to make a quick correction on my calculator screen. Alright, looks like I lost it. That's okay, I'll retype. So 1 plus 4, and then it's e to the 15k. E to the 15k, and I have k stored properly. 37.317 if you round. 37.317. And the only thing I want to say about this is that this is one of those situations where something is growing towards 50 of something. So maybe it's like there is a zoo and there's a cage that can support 50 rodents or something. And so, it always sounds sad to put rodents in a cage. But anyway, the population is growing towards 50, and at time 20, the population is 43 and a half, and we found out that at time 15, the population is 37.3 or so. So maybe these aren't rodents because you can't really have decimals on the rodents, but this could be some other phenomenon where decimals do make sense. You know, like even like a temperature or maybe, you know, the voltage of a capacitor is rising towards 50 volts or something. Alrighty, so that's Logistic. That's our Chapter 4 test, and good luck, or not good luck, but I hope and pray you do well in the final tomorrow. Alright, email me if you have other questions.